Assalamualaikum warahmatullahi wabarakatuh.
My name is Naila.
My name is Alifia Aflah.
My name is Afif.
My name is Raihan Al-Fajr.
In this video, we are going to talk about alcohol. Alcohol is the hydroxy derivative of aliphatic hydrocarbons. When one, two, or more hydrogen atoms of hydrocarbon are replaced by a corresponding number of hydroxyl groups, alcohol can be obtained. These are the properties of alcohol. The first one is the polar, which means the OH group readily forms hydrogen bonds. The second one is it is miscible with water. The third one is the longer alkyl chain, the van der Waals attraction predominate and decreases the miscibility with water. The last one is the boiling point increase as the number of carbon atom increases due to stronger van der Waals. Now, nomenclature. Nomenclature is a set of rules to generate systematic names for chemical compounds. As with other types of organic compounds, alcohols are named by both formal and common system. The name for an alcohol uses the OL suffix with the name of the parent alkane, together with a number to give the location of the hydroxyl group. The rules are summarized in a 3-steps procedure. So, the first step is name the longest chain that contains the carbon atom bearing the OH group. Drop the final E from the alkane name and add the suffix OL. The second step is number the longer carbon chain starting at the end nearest the OH groups, and use the appropriate number, if necessary, to indicate the position of the OH group. And the last step is name the substituents and give their numbers as for an alkane or alkene. The next one is isomerism of alcohol. There are 4 types of isomerism: chain, position, functional, and optical. Chain isomerism. Alcohols with 4 or more carbon atoms exhibit this type of isomerism, in which the carbon skeleton is different. Position isomerism. Alcohols with 3 or more carbon atoms can exhibit position isomerism. In this type of isomerism, the position of the functional group OH varies. In other words, the carbon atoms to which the OH group attach is different. Functional isomerism. Alcohols with 2 or more carbon atoms can exhibit functional isomerism with ethers. Thus, ethers and alcohols have the same molecular formula but have different functional groups. Hence, they are called functional isomers. Last one is the optical isomerism. Alcohols containing chiral synthesin exhibit enantiomerism or optical isomerism. The optical isomers can rotate the plane of plane polarized angles in different directions.
Now we're going to talk about combustion. Combustion means burning. Yeah, it burns, and this is the equation. It's just alcohol react with oxygen, forming carbon dioxide and water. Now, see that when less oxygen is present, an incomplete combustion will occur, producing water and either carbon monoxide or carbon. The carbon here is only mono, not like this. This is dioxide, which has 2 oxygen. This one is only has 1 oxygen because the oxygen is less in this reaction. And this is the equation. See that same alcohol react with oxygen, the amount is different, and forming carbon monoxide, which is less than carbon dioxide, and they are forming the same water. Now we can see that combustion is divided into 2, which is complete combustion and incomplete, and combustion is used as a fuel. Now we're going to talk about sodium metal, the reaction of alcohol with sodium metal. This is the equation. It's just ethanol added with sodium, and it's forming sodium hydroxide. with hydrogen gas. This reaction is similar to sodium's with water, but this one is less vigorous due to the density of this. Now, when the ethanol is evaporated off after this reaction, a white crystalline solid is left. This is forming a white crystalline solid. It looks like a salt, like a usual salt. And the longer the hydrocarbon chain, the less vigorous the reaction. There you go.
Reaction with sodium metal and esterification, breaking OH bond. Alcohol could be used to produce hydrogen by reacting it to a sodium metal to break the OH bond in alcohol. Compared to sodium metal and water reaction, this reaction is less vigorous. The product of the reaction is, aside from the hydrogen, is named sodium ethoxide, white solid that's soluble to both ethanol and water. Esterification. As the name of it, it produces the product ester and water. And alcohol does that by reacting to either carboxylic acid or acyl chloride. Esters are useful solvent and sometimes used as flavoring agent. It has been found that the oxygen in the water comes from carboxylic acid, while the one that made the ester bond comes from alcohol. Let's move to the question.
Breaking COH bond, nucleophilic substitution. What it means by nucleophilic? It contains two words, nucleo and philic. Nucleo means nucleus, that means it positive charge. Philic means loves or likes. So, nucleophilics mean any of atom or compound that loves positive charge of any atom or compound. It means the atom or compounds of nucleophilic is negative charge. Nucleophilic substitution occurs when the alcohol reacts with hydrogen halide and it becomes halogen alkane and water. There is a very brief moment where the reaction made up a carbocation before when to finish the process. This process called SN1, and there are many reactions, but there is a special condition that is when alcohol reacts with hydrogen chloride. So, as you can see, there is an observation with alcohol react with hydrogen chloride. In tertiary, it will immediately cloudiness appear in the solution. In secondary alcohol, it will cloudiness apparent with 5 minutes. In primary alcohol, no cloudiness apparent unless warm.
Breaking COH bond. Elimination. Alcohol, upon reaction with protic acids, tends to lose a molecule of water to form alkenes. These reactions are known as dehydrogenation or dehydration of alcohol. It is an example of an elimination reaction. Its rate varies for primary, secondary, and tertiary alcohol. Alkenes can be formed from the dehydration of alcohols, where a molecule of water is removed from the molecule. In order to do this, excess of hot sulfuric acid is added and aluminum oxide is used as a catalyst. Dehydration of alcohols can follow E1 or E2 mechanism. For primary alcohols, the elimination reaction follows E2 mechanism, while for secondary and tertiary alcohol, elimination reaction follow E1 mechanism. Generally, it follows a three-step mechanism. The first step is formation of protonated alcohol. In this step, the alcohol is acted upon a protic acid. Due to the lone pair present on oxygen atom, it acts as a Lewis base. Protonation of alcoholic oxygen takes place, which makes it a better leaving group. It is a reversible step which takes place very quickly. The second step is carbocation formation. In this step, the CO bond breaks, generating a carbocation. This step is the slowest step in the mechanism of dehydration of an alcohol. Hence, the formation of the carbocation is considered as the rate-determining step. The third one, alkene formation. The proton generated is eliminated with the help of a base. The carbon atom adjacent to the carbocation breaks the existing CH bond to form C double bond C. Thus, an alkene is formed. This reaction means that addition polymers can be produced from fermentation without the need of crude oil, a non-renewable resource. Fermentation produces the primary alcohol, which is dehydrated to produce an alkene used in the production of addition polymers. So we have 4 isomers with the formula C4H9OH, and we need to complete the naming of the isomers in the table above. So we have 3 carbons from the longest chain. So this is the first one, the second one, and this is the third one, right? So because we have 3 carbon, it's going to be a propane, and there's a branch on the second carbon, and it only has 1 C. So it's going to be methyl, and it's on the second carbon from the longest chain, so it's going to be 2-methylpropane. And this one, the OH, is on the first carbon. So the name of this isomer is 2-methylpropane 1-OL. Now the next one, it has 4 carbon on the longest chain. This is the first one, the second one, third one, and the fourth one. Oops, okay. As you can see, it has 4 carbon on the longest chain, so it's a butane. And there's also a branch of OH on the second carbon, so the name of this isomer is butane 2-OL. Okay, the next one, name the type of isomerism shown by these 4 isomers. It is really clear that it has the same molecular formula, which is C4H9OH, and it has different atomic arrangements. Also, it has the same carbon skeleton, and they have the same functional groups. So it is really clear that the isomers for 4 of this reaction are chain and positional isomerism. Which pair of alcohols are isomers of each other? The answer is B, butane-2-ol and 2-methylpropane-2-ol. Why? Because both butane-2-ol and 2-methylpropane-2-ol have the same isomers, which is chain and positional isomerism. The chain isomerism is when both isomers have the same molecular formula but different atomic arrangements. Meanwhile, the positional isomerism is almost the same. Both has the same carbon skeleton, and they have the same functional groups but different position of the functional groups.
Now we're moving to the question. So I have a question here. The flow chart shows the preparation of ethanol and some important chemistry of ethanol. The substance X with fermentation forming ethanol, and then ethanol with process Y forming carbon dioxide and substance Z. The question is, what are X, Y, and Z? Look at this option and look at this. First thing, we have carbon dioxide here. Remember what reaction is forming carbon dioxide? Yes, it is combustion. Remember this, alcohol plus oxygen forming carbon dioxide plus water. So we have the same carbon dioxide here, and the polymerization is not fermentation. No, they're not forming carbon dioxide. And then the combustion is also producing water, so when carbon dioxide plus water, so this substance Z is water, and the process Y is same with this process. Now look at this, the combustion, dy we have two combustion, but in Z we have yeast and steam. Now which one is the water? Obviously not yeast, because yeast is not a water, and steam, yep, because the water in the combustion is in the form of water vapor or steam. And then, yep, the answer is B. Yay. Next, we have this question. Which statement about ethanol are correct? 1. It can be made by fermentation. 2. It is unsaturated compound. And 3. It burns in air and can be used as a fuel. Now look at this. 1. Can ethanol be made by fermentation? Yes, it can be made by adding a sugar, so this one is correct. Now, it is an unsaturated compound. Since ethanol is there are no double bond or triple bond, they are saturated, so this is false. And it burns in air. Yes, it combusts and can be used as a fuel. Yeah, it's true, so the 3 is correct. Which one? 1 and 3. The answer is C. Yay, finish.
Here, part of some question in 2019 past paper. Here we can see the structure for V and W are shown as above. You can see. Name the class of compound that V and W each belong to. We can see that there are hydroxyl functional group on both compound, means they're both classified as alcohol. See? Yeah. Number 2, V and W both react with sodium metal. As our topic, react with sodium metal. Now, I'm going to teach you how to write the equation for it. Bam. So that's how it reacts in an equation, supposedly. To the next question, we're going to discuss esterification. Another one of the question from the past paper from 2005. What is the structure from the ester formed from propanoic acid and ethanol? So, propanoic acid would be 3 carbon long with carboxylic acid chain at the end of it, while ethanol would be 2 carbon long compound with hydroxyl group at the end of it. The reaction between the two would be this, B. The formation in B would compromise the fusion between the two. On to the next question, also esterification. Also came from the past paper, but this one is from 2004. Acarol is sold as an insecticide for use on fruit and vegetables. The final stage of its manufacture is an esterification, which alcohol is used to form the ester. As we learned before, the oxygen within the ester are made up from the alcohol. The alcohol. This one came from the alcohol. Thus, this part came from the alcohol. If we make this portion into the alcohol, it will compromise into this propanol, propan 2R, because the hydroxyl group are connected to the second carbon within the longest chain of the compound. Yeah, that's all for the esterification.
Which alcohol can be dehydrated to give two products which are structural isomers of each other? So, these questions ask for two possible alkenes. So, we can use elimination. For answer A, it will be one possible alkene, and for B, it will be two possible alkene, and C, it will be one possible alkene, and D, it will be one possible alkene. So the answer is B, because when we use elimination, it becomes two alkenes for the product. Bromomethane is used as a fumigant to destroy insect, pests, in grain that is to be stored. It can be made by reacting methanol with hydrogen bromide. What type of this reaction? By the hydroxyl switch position with bromine after the reaction. It will be called substitution, and because of bromine is negatively charged and attracted to the positive polarity, thus it is nucleophilic. So the answer is D, nucleophilic substitution.
Assalamualaikum warahmatullahi wabarakatuh.